the previous video we looked at Gaussian processes to model time series. In this video we're going to use a slightly different approach and we're going to model the time series directly. So we're going to model the underlying process. And an obvious example of modeling such a time series, at least after 2020, is to model an epidemic. Yeah, because we know that epidemics have exponential growth, so we can model the exponential growth ourselves. So we don't need a Gaussian process for that, or if you use more old-fashioned time series approaches like an AR or an ARIMA model. This is going to be different because here we model directly the process that actually generates the number of cases in an epidemic. So we're going to look at some COVID data. And in particular, we're going to use this library here, covid19pandas, which gives us the John Hopkins University data on corona cases around the world. It takes a bit of time to run this code block, so I've already done this, so we don't have to wait on video. And basically what you get is, so I define here this global data frame, global in the sense that it contains all the countries. So from this covid19pandas library, we use the get data John Hopkins University, JHU method. So it gives us a data frame, a standard pandas data frame, and we can look at the head of that data frame. So this is basically what it looks like. So we get a number of columns. So it gives information on population, cases, and death. And it has a column on country or region. Yeah, so we're not going to analyze this data for all countries in the world. We're going to make a selection on which countries that we're going to be interested in. So let me start, and we're going to make this selection. So we're going to say, if I look at my data frame, global data frame, and I'm looking at this column, country region, then we can look at all the countries and regions that are actually in our data. Yeah, so there's alphabetic ordering, so that's easy. So, you know, there are lots of countries in this data frame. Since I'm recording this video in the Netherlands, I will make a selection that we're going to be focusing on the Dutch data. So I'm going to define a new data frame, which is just for the Netherlands. So there is the method here, select regions. So the data that we'll be looking at is our global data frame. Region col is in this case combined key, and now we can select our region. So regions equals, so we're going to be interested in Netherlands. And just to get an idea of what this looks like, so usually we use head in this case, but now we'll use tail, and I'll show you in a second why. So this is what our data frame for the Netherlands looks like. So it has the same columns obviously as the global one. So I've used a tail here to get the last number of a couple of rows in this data frame, and you can see that when I'm making this video, the data goes all the way up till October the 20th in 2021. Yeah, so if you're running this command at some later date, you're going to have more dates here and later dates here as well. Yeah, so this is what we're going to be working with. So we have the column cases. So something that's also going to be interesting is the number of new cases. So basically that's the difference day on day. As you can see, these are the 20th, the 19th, the 18th. So if I take the difference between each of these rows, I get the increase in the number of cases. So let's create that column. So from my newly created data frame for the Netherlands, I define new cases. And that's going to be equal to, from my data frame, NL, I'll take the cases column, and then I use the diff method. Yeah, so we can run this. That doesn't give any output, it just creates a new column. And then just to get an idea of what's going on, let's plot this column. So we'll do plt plot. Plt plot from our data frame. We're going to plot date against new cases. Yeah, so it gives me the graph over here. So here you can see the development of new cases in the Netherlands starting in 2020, going all the way up till almost November 21. A bit of a problem is, of course, that these labels overlap. So we can do something about this to make the horizontal axis easier to read. So in matplotlib, there is this xtix where we can say that the rotation is going to be 90 degrees. Yeah, so now it's a bit easier to read. So the data starts a bit after January 2020, and then here we have March, May, etc., and it goes up till, but of course not including, because I'm recording this in October, so it's not including November, but we're getting close to November. So the idea is here that this part, so when the pandemic started, should feature exponential growth. So this is the part that we're going to model. So of course for exponential growth we need to start at a point where there are actually some cases, because if there's no case at all you can't get exponential growth. So we need to have some cases. So we're going to start in May 2020. So there's this small bump over here which we're going to skip. So we start here in May 2020 and we're going to see whether we can then model it all the way up till November 2020. Because after that, of course, there were corona restrictions, so things go down again and they went up again and down, and at some point the vaccination starts. These are things we're not going to model in this video, but you can think about this yourself, about how you would like to capture in your time series the fact that there were corona measures and there was at some point the vaccinations were introduced. But in this video we're just going to try to capture this part here where we have something close to exponential growth. So I'm going to make that selection of our data. So I'm going to define a new data frame df. This is a data frame that we're going to be working with later on. So from my data frame for the Netherlands, I'm going to make a selection. I'm going to say data frame Netherlands date. And I'm going to use the between method. So I'm going to be interested in the data between 2020, 05, 01, and we're going to stop at 2020, 11, 01. So not including November 2020, but going all the way up to 2020. And then just to get an idea what that looks like, df date, I'm going to plot it against df new cases. Yeah, so this is the part that we're going to plot. And we're going to see whether we can sort of match this with an exponential growth model. Yeah, but to finish off, let's also plot the number of cases itself. Yeah, so not only number of new cases, but also number of cases. So plt plot df date df cases. Let's add. Yeah, so here we also see the exponential growth pattern, and this is the thing that we're going to try to model using PyMC3.